All right. Well, welcome everyone. Jesse Porter from InSpire here, and I want to thank you all for joining us today for this webinar titled Measuring Success, Key Performance Indicators for Cannabis Cultivation. Today, InSpire's Cannabis Operations Specialist, Anders Peterson, and I will present some of the performance indicators we value for their ability to influence cultivation, engineering, and financial decisions. They are measurable, actionable, and influential. And we didn't just want to list a bunch of KPIs and hope that they resonate with our audience. We know everyone values certain KPIs more than others, and we wanted to present KPIs that we find useful and realistic to guide managerial decisions. Now, when I started cultivating at scale in the early 2000s, due to the lack of technology available, most cultivators were just starting to think about VPD. Integrated environmental control didn't really exist yet. We didn't invest in water activity meters to safely cure in the process. We just burp bins in a storage room. We weren't measuring leaf temperature to determine the best offset. We just gave the plants what we thought they needed based on experience and what we saw. And I used to blame my conventional HVAC system because I would always be battling swings in temperature and humidity. I would blame the engineers who did the calculations wrong, the manufacturers who build inferior units, and the people that allowed me to buy comfort cooling for my CEA space. For me, HVAC was a four-letter word and my biggest limiting factor. Things have changed in the cannabis industry, and that's why I'm proud to be a part of the InSpire team. Just like the advancements we see in LED lighting technology and fertigation, integrated HVAC-D systems allow us to refine curing cultivation practices in ways not possible before, to drive performance to new levels, to create truly repeatable processes, and to build facilities that are competitive for 5 years from now. Precision control and of temperature and humidity with an integrated system are necessary. It gives you the granularity of data needed to improve every run and explore the limit of what you're capable of as a cultivator. And today I notice the most successful cultivators I speak with have some things in common. They love data, they know systems, they know cannabis plants, and they know their goals. Most importantly, they use the data they collect to influence systems they own to optimize performance of their plants and overall facility. And that brings us back to the importance of KPIs. We talk about KPIs every day, debating the merits of each one against each other, the levels of interconnectivity and influence, the relevance, the ability to measure. It's ever evolving. And today we're here to talk about the KPIs we see being applied and having significant influence for our cultivation partners. We organize them under 4 pillars of financial performance. The first pillar is quantity. How much sellable cannabis product do you produce is about influencing top-line revenue. The next 2 pillars are quality and consistency and are at the heartbeat of every brand, and they combine to give you pricing power in a competitive market. And the 4th pillar is efficiency, which will lower the cost of production and increase margins. Together, these pillars have allowed us to prioritize KPIs that make the biggest financial impact in a cannabis cultivation facility. These pillars also fuel the development and deployment of InSpire's purpose-built integrated HVAC-D systems for cannabis. Our goal is to empower our partners with the environmental control needed to drive KPIs by optimizing plant health and future-proofing their businesses. And with that, I'll let Anders take over and frame the conversation on KPIs and get us started.
Thanks, Jesse. I appreciate everyone joining today to listen to our presentation. To me, the theme of today's talk is very much looking into the future and how we can run these facilities like a well-oiled machine. And KPIs play a big role in that future. With that said, what is a key performance indicator? A KPI is a set of quantifiable measures that a company uses to gauge its performance over time. They are a measurable value that demonstrates how effectively a company is achieving their business objectives. Too often, organizations just blindly adopt industry-recognized KPIs and then wonder why that KPI doesn't reflect their own business. And that's because for every organization, KPIs are bespoke. A greenhouse grower at 1 million square feet will have different KPIs than an indoor grower or a vertically integrated business. Establish KPIs that will benefit you. When establishing KPIs for your business, start with the basics of understanding what your objectives are, how you plan on achieving them, and how you will act on this information. Establishing KPIs should be an iterative process that involves feedback from industry professionals, department heads, and managers. One way to evaluate the relevance of a KPI is to use this SMART criteria. SMART typically stands for specific, measurable, attainable, relevant, and time-bound. In other words, is your objective specific? Can you measure progress towards that goal? Is the goal realistically attainable? How relevant is the goal to your organization? And what is the time frame for achieving this goal? SMART will help identify high impact opportunities for you. And this will help you narrow your focus on the important aspects of your business and where to allocate resources. Keep in mind that not everything you can track or collect data on in a grow is a KPI. Many are metrics. Metrics are used to set processes. After setting metrics, a cultivator's job is to note deviation from a process. And if that deviation is positive, then it becomes the new SOP. Things like VPD target ranges, PPFD values, and EC are metrics, not KPIs. KPIs always tie back to financials. Now let's discuss some of the primary KPIs associated with the first pillar, quantity. One of the most impactful KPIs to a cultivation business is yield. Revenue is impacted by quantity, quality, and consistency, but quantity is the clear revenue driver. And the best way to achieve quantity is through the appropriate genetic selections and precision management of all the plant growth parameters. Historically, cultivators quantified yield as pounds per light, but for reasons that we will go into shortly, this is not a scalable or accurate method of quantifying yield. The most prominent method today is grams per canopy square foot of flower. As straightforward as this KPI seems, you'd be amazed at all the different interpretations of how this can be quantified. What exactly makes up the grams portion of this KPI? A grade flower, B grade flower, trim? In a few slides, I'm going to show you how I approach this calculation and why. Another way of looking at yield, especially if your entire harvest will go to extraction or infused products, is active compounds per square foot, either in milligrams or grams. Now, at its essence, cannabis is just a bioreactor, and it produces secondary metabolites of interest and value. And dry flower is hardly the most efficient delivery mechanism. Formulary products are shaping a lot of things in this industry, and it makes sense to focus more on the active compounds produced than the biomass. The lab report in hand, this is easy to calculate. For instance, 20% total cannabinoids is the same thing as 200 milligrams per gram. Times that by the amount of biomass produced and divide by the canopy footprint, and you have active compounds per square foot. Now, the first two KPIs above are looking at yield in a per batch scenario. But for long-term goals, it is also important to look at the total productivity of your facility or multiple facilities if you are an MSO. And this is straightforward. Total grams produced per year times the total canopy square feet of your facility times the total harvest cycles in that year. Through genetic selection, strict management of your plant process flow, and precision control of your plant growth parameters, you can shorten your veg and flower cycle times, increase your grams per square foot, and the total cycles your facility can complete each year. Therefore, increasing total production capacity and driving top line revenue. Jesse, tell us some of the secondary KPIs for quantity.
Thanks, Durs. Some of the secondary KPIs we talk about often are extraction yields, crop loss, CO2 assimilation, and flower yield per cultivar. And first we have extraction yields per cultivar, per flower cycle, per year. This one can be pretty straightforward. How much did you extract? How many active compounds were you able to preserve? Did you get the most from that cultivar? Is there a better cultivar to meet your goals for extraction? The answer to those questions and more lie in the extract yield. Next is crop loss. So crop loss due to pests, pathogens, or other destruction. This can be what doesn't sell, or in the case of a failed test, how much product needs to be destroyed. Crop loss is devastating, as any experienced cultivator will tell you. Many of us have experienced the horror stories of losing whole rooms due to pests. Pathogens like botrytis, which are triggered by a lack of dehumidification control, will compromise plant health and lead to failed microbial tests. Inventory is now obsolete. Even small amounts of botrytis can destroy terps, limiting the harvest of active compounds from flower through curing and extraction. And any pest pressure that requires IPM applications will affect plant growth and reduce yields. The best way to limit destruction of product and achieve the most expression is to tailor 24-hour environmental conditions for each cultivar. And one way to tell if each cultivar is operating at peak metabolic rate is measuring CO2 assimilation per lights on photo period. By collecting CO2 assimilation data and understanding the CO2 assimilation per cultivar, you'll be able to determine if your plant or room is on pace or lagging behind your performance goals. And speaking of performance goals, we always talk about flower yield per cultivar. This is measured in grams per square foot, but it also allows you to right size your canopy allocation to meet the demand for a finished product. But it's so much more than that. A unique cultivar is a great way to serve the evolving market and also explore the highest possible quantity per canopy square foot at your facility. So with that, how do we measure quantity?
Yeah, I want to go through an example of how I calculate grams per square foot and dive into the details. Now, like I mentioned previously, pounds per light was the predominant yield KPI for many years. Most growers had a similar setup of 2 lights hung over a 4-foot by 8-foot tray. But as lighting and racking designs progressed, that standard soon became obsolete, and this KPI stopped being an effective way of communicating yield. As you can see in the tables here, as the footprint of my lighting fixture changes, pounds per light loses its ubiquity. The grower who yielded 3 pounds of light under a 4-foot spread yielded 36% more than the grower under a 5-foot spread per square foot. It can become misleading. We needed a more universal KPI for quantity. By representing your yield over canopy square feet instead of lighting fixtures, it now becomes an even playing field. Canopy square feet is calculated by adding up the total footprint of the grow benches or trays in each room, as shown here in this example layout from our friends over at PIP. The real nuance of grams per square foot is how you add up the total grams of flower produced for that harvest. Here, we are looking at a grams per square foot calculation in both an unadjusted and adjusted scenario. With unadjusted, we just include all the flower we yielded from that run. A lot of growers go this route. That's because it makes them look good. 67 grams a square foot is a lot better looking than 59. You always want the highest yield, right? In the adjusted scenario, I derated the Class B flower by 25%. And you can derate your Class B by however much you want, but we do this simply because it sells for less than Class A. When presenting results to an investor, they want to see a number that is representative of the value of that harvest, because grams per square foot of flower directly ties back to price per pound. Investors don't care about Class A to B ratios, but as cultivators, we absolutely should. Obviously, we want more Class A than B. If we don't derate Class B, we leave noise in our decision-making for which cultivars to grow and how much canopy to allocate to that cultivar. Say we are choosing between 2 cultivars to grow, and one yields much more Class B than the other, and we do not derate or adjust. Then we are fooling ourselves about the value of that harvest. Now, on your investor class updates, it can still be worthwhile to include both unadjusted and adjusted. Use the unadjusted figure to compare to legacy style grows as a baseline. You might be wondering where trim is in this equation. And it's not shown here because we are talking grams per square foot of flower. We for sure track trim and count it. It's just not in these figures because it usually sells for like 15% of what Class A does. We account for it separately. You could include it in an unadjusted figure, but really as a means to identify failures in processing, like rough handling that caused a higher amount of trim than usual. So I often get asked by newer growers, what is a good yield? And that's pretty subjective, depending on your goals and if you're going for quantity or quality. Some of the more desirable and exotic cultivars to smoke are not always the best yielders. But in a general sense, anything below 30 grams a square foot is a low yield. Around 50 is pretty average. And if you are consistently getting over 80 grams a square foot, then you're getting high yields. Now, these ranges may be different for you based on your goals and cultivars you have. KPIs change as your business models change. For reference, I've done many financial projections for grow facilities, and I personally like to use something in the 45 to 55 grams per square foot range to base all of my projections off of. I would always rather under promise and then over deliver. And I think that is a safe number to impress your investors with, and for a competent grower with good genetics. Jesse, give me some more tips on how I can increase these KPIs.
Thanks, Durs. I think I'd like to take a quick look at this graph and talk CO2 due to its correlation to biomass creation. On the graph, you see the black line is an indication of CO2 assimilation and ultimately stomatal activity. The tighter band at the front of the graph shows the solenoid opening and closing, dosing high levels of CO2 in the room due to assimilation by the plant. Then right around 2 p.m., there's a foliar application that's indicated by that red arrow. Immediately following, you can see that the solenoid opens more slowly and the plants are, metabolic rate has been slowed. She's just using less CO2 for the whole second half of the day. From a financial impact perspective, what does a once a week IPM spray cost you in biomass? Let's think about it. Every week of an 8 or 9 week cycle, half of the day, once a week, your plants are underperforming. Or once a week, your plants are underperforming. That's 7% of your bottom line. 7% of the bloom cycle, with a limited opportunity to develop secondary metabolites. Obviously, this can impact your test results and pricing power. In addition to that, CO2 assimilation can be an effective way to determine if you have appropriate airflow in the space and that the CO2 is getting directly to the stomata. In addition, light intensity plant training, 24-hour VPD control will allow you to reduce the number of small buds and focus on increasing production of your grade A flower. And with an integrated system, you're able to create conditions that optimize the 10 cardinal parameters of plant influence, which, as Durs mentioned, will shorten cycle times and allow for cultivar optimization and selection that best fits your business goals. Furthermore, when it comes to curing, understanding moisture content allows you to safeguard against excessive moisture loss, reductions in sellable weight, and provide consistent customer experience. Investing in systems that make this possible will increase your overall yield. But what about quality of that yield? Durs?
Yeah, let's move on to quality. There are many intangible or subjective ways to judge the quality of cannabis. People who have been around and smoked a lot of good weed just know when they open that bag or light that joint, the level of quality that is there, whether it's kind of mid-grade or really something special. But that is not a quantifiable or consistent way to measure quality. There are two primary KPIs today that are used to quantify quality, albeit indirectly: price per pound and a certificate of analysis or lab report. Quantifying price per pound is self-explanatory. The higher price per pound you're able to fetch typically trends with the quality of the product, although this depends if you are a price taker or a price setter. It's about pricing power, and pricing power manifests through quality and consistency. The regulatory framework of the state you are in can shape who has pricing power along the supply chain. But as a producer, if you time and time again have a consistently high quality product, your pricing power goes up. Genetics and maximizing your phenotypic expression through precision environmental control directly impacts your price per pound. But how do you convince the buyer you're dealing with the quality of your product? The legal market today makes that difficult. 10 years ago during Prohibition, when I was buying pounds, I would sit down with a bunch of bags in front of me, smell the product, smoke some joints, and negotiate price. Nowadays, you usually don't even get to see the product you were going to buy or sample it before buying. It's all done with spreadsheets and lab results. When it comes to negotiations, the COA plays a pivotal role, potency and terpene content being the most important factors. The higher the potency and terpene content usually demands a higher price. If my fatso cut is testing over 40%, you betcha I'm gonna demand a higher price than my purple punch that is testing at 18. These two KPIs are arguably the most important when it comes to quality, but there are many other factors. Jesse, what are some of the secondary KPIs for quality?
Well, some of the secondary quality KPIs we talk about are bag appeal and number of touches. And bag appeal is a great one, but it is hard to measure. Density, structure, color, nose, hype, name, brand. Was it machine trimmed versus hand trimmed? These things factor into the value of the finished product. And while it's not easily quantifiable, every facility can establish baselines for bag appeal. It just can't be overlooked. For example, heat stress is one of the causes of foxtailing that you see an example of in the picture in the upper left-hand corner. This negatively affects bag appeal and has a high likelihood of being destroyed in the processing process. The way cannabis is processed has a dramatic effect on bag appeal. The process from harvest through handling and curing will affect the quality, and the more touches, the less likely your products are to be valuable. You're going to lose more valuable compounds. Was it tumbled through a trim machine in order to get to the market faster, or hand trimmed to increase value and preserve secondary metabolites? Was it sprayed in late flower to fight off powdery mildew? Was it cured in a room or burped in a tote? There are a variety of different touches, all of which have a negative impact on quality. Reducing touches will result in a cleaner, higher testing product that is more valuable to the consumer, while also reducing the costs of production. And when it comes to curing at scale, I see this as a major pinch point. If your systems can't remove enough moisture in the first few days, your cannabis will rot. If you remove too much moisture, your product will lose value. With precision moisture removal from systems built for curing, you can control the moisture content of the final product and eliminate secondary curing procedures. This predictability in curing removes variable moisture content from the equation, eliminates pathogen risk, and improves bag appeal. It also shortens the curing process so you can get to market faster. This can have a negative impact on the speed and quality associated with your brand. You need to get to market quickly, but have a great product, and truly understanding how to utilize the systems that you purchased will impact your process. So how do we measure quality, Anders?
Well, like I just mentioned, COAs play a really important role and in negotiating price and quality. So it's important to understand how these potency values are generated and the variability that exists in the process. Taking the same sample to different testing labs can yield results that vary by as much as 20%. As of today, there are no nationwide standards for testing labs and their protocols. As such, many labs go about this process in similar but slightly different ways, which can skew results. High performance liquid chromatography, or HPLC for short, is the most common method and can quickly identify and quantify cannabinoids without heating the sample. But variability still exists, even with these precision machines. One of the biggest variables is the moisture content of the flower. And this is because cannabinoids are measured as a percentage of the product's total weight. So if the sample is dried out, it will weigh less than a sample with more moisture. Both samples may contain the same amount of THC, but the test will show that the drier cannabis is more potent on a percentage basis. And as the moisture content goes up, the product will weigh more due to the water, but will have a lower potency on a COA. Ideally, all cannabis would be sold, processed, and tested at the same moisture levels, but that's just not the case. This balance between more sellable weight or a higher potency is determined in the dry cure room. This is exactly why we spent so much time developing an integrated, purpose-built drying and curing system that allows the cultivator to dial in their final moisture content precisely. We want to provide you the tools to be able to make that decision yourself. Along with moisture content, plant and cultivar variations also influence the potency. Potency varies between individual plants and cultivars, as well as how well that cultivar was grown. So with that, Jesse, how can we improve our quality?
Well, I think one of the major things to build on here is thinking about moisture control. One of the major elements impacting the quality of cultivated and cured cannabis is your ability to control the moisture. This is one of the reasons we focus so heavily on the pound per hour moisture removal metric. Right sizing for the latent load is critical to plant health. Anaerobic water conditions in the room will develop water molds like Pythium, and anaerobic water on the leaf surfaces will cause powdery mildew and botrytis. That's one reason dehumidification and airflow are so imperative to consistent production of quality products. We need to prevent anaerobic water conditions in the room and on the plant to avoid pathogens and maintain healthy growth. But we also use dehumidification to drive transpiration, which in turn drives nutrients through the plant, especially immobile ones. So to avoid pathogens and nutrient deficiencies, you need to accurately control the temp, humidity, and target VPD in the cultivation space with an integrated system that's appropriately sized. Then, in curing, we like to focus on a room that limits touches, as mentioned previously. We also find it imperative to gain control on water activity to prevent late-stage bud rot. By focusing on moisture control with your integrated system, you can see the metrics you need and manipulate the set points to become a driver of quality from cultivation through curing. Pocket dehumidifiers and mini splits create variable conditions that force you to rely on the artistry of curing and cultivation, not the science. When you think about scaling a process and understanding the why, you will have to make decisions based on data and not just what your eyes, nose, and fingers tell you. Which brings us to the importance of consistency.
Primary KPIs for consistency. Arguably the most important of the 4 pillars. Along with quality, consistency drives pricing power. And to have a consistent product, you must have tight control over all your variables and plant growth parameters. Control equals consistency. Whether you like it or not, consumer packaged goods companies and big pharma will soon be players in this industry and bring with them significant capital and resources. But for now, they are waiting on the sidelines. Regardless of federal law, consistency is the #1 prerequisite for these players to enter the space. When building your indoor cultivation facility, view it as an asset. Invest in technology like integrated HVACD so that you can have control and consistency. This will allow you to have a much bigger valuation and make you a target for acquisition. When it comes to consistency, now we're talking about metrics, not KPIs. Remember, metrics track a process and KPIs tie back to financials. But that's okay. Metrics and KPIs do not exist in a vacuum. Cultivation metrics that are used to track the consistency of your process in the end influence the financial KPIs downstream. Cultivation metrics are what most growers spend their time discussing and analyzing. Environmental metrics like temperature, relative humidity, and VPD. Lighting metrics like PPFD. Fertigation metrics like EC, pH, and mineral balance. In fact, really all of the control that is necessary to achieve consistency is really to just maintain balance. Balance within the plant and balance within the room. There are 3 main balances to be aware of in controlled environment agriculture: the energy balance, the water balance, and the assimilate balance. And if you are not familiar with these concepts or balances, I highly recommend reading the book, Plant Empowerment. It's one of my personal favorites. Now, not all grow rooms are able to achieve control and consistency. It takes investing in the right technology, as we've said. Just look at the two trend graphs here. The one on the left shows data from our integrated system with no more than a 2-degree deviation from temperature set point and 2% from relative humidity set point. Even during the lights on to off transitions, this data, and furthermore, this data is recorded once a minute with over 12 temperature and relative humidity sensors across 3 vertical tiers of canopy. And on the right, a legacy system where temperature fluctuates plus or minus 8 degrees and relative humidity spikes 20% every day when the lights go off. The lack of humidity control throws all of the balances off in the room and leads to pest and pathogen outbreaks and a reduction in yield. To future-proof your business and stay competitive, you must have control.
Thanks, Durs. We talk about a lot of secondary KPIs for consistency: adherence to set point, curing success, CO2 again, IPM applications. And adherence to set point is something that every cultivator thinks about. We all have environmental control targets. We choose these targets for a reason. But what is the cost for operating outside those target ranges? How long before those deviations make a financial impact? These suboptimal conditions reduce the plant's performance and cost you money. Now, controlled stress is a great tool to bring out generative growth and trigger senescence. It can be built into the SOP. But consistent environmental stress is a byproduct of poor facility design and inferior technology, and it's a competitive liability. Limiting the time you spend outside healthy VPD ranges will produce better and more consistent cultivation results. Precision control will allow you to establish realistic performance baselines and have more predictable outcomes. And measuring curing success is all about preventing volatility of secondary metabolites and preserving the hard work of the cultivation team. In order to track and measure success in curing, we can focus on some of the previously mentioned KPIs or metrics: moisture removal rate in pound per hour, adherence to set point, water activity, and we can introduce moisture content into curing. Controlling the moisture content of your flower during the curing will impact shelf life, influence COAs like Durs mentioned, and provide a consistent customer experience. If you deviate from your set point, you'll lose opportunities for optimal CO2 assimilation and lessen potential yields. And as mentioned, consistency in CO2 assimilation is an indicator of good airflow, healthy plants, stomatal conductance, and predictable and optimal yields. Suboptimal conditions also create opportunities for pests and pathogens to take hold, and they're going to require a higher rate of IPM applications to maintain the baselines for production. And as we have seen, how often and what time of day you apply preventative IPM applications will have an impact on quantity, quality, and the consistency of the flower you produce. We like to say consistency is key. It's key to branding. Look at Nestle, Starbucks, or even the Oreos I had with my kids last night. Customer satisfaction is based on consistency. I knew the flavor, texture, and experience I would have dunking those Oreos with my kids. And that's why I bought them instead of another chocolate sandwich cookie. It's the same experience I had with my mom when I was a kid. Predictability is key to pricing power and long-term staying power of cannabis producers around the world. It's also one of the biggest obstacles for scalability in cannabis cultivation. So how do we measure consistency in cannabis cultivation?
Well, sensors, other measurement devices, and software to monitor and analyze your data are the day-to-day tools necessary to maintain control. Not all sensors and measurement devices are created equal. They vary in accuracy, precision, resolution, and sensitivity. Choosing the right sensor starts with understanding what you are trying to do with that data and how precise you need that measurement to be. Rank the metrics you want to track by importance, determine the accuracy at which you want to monitor that variable, and select the technology accordingly. If I want to maintain precision control of my environment, would I settle with a sensor that has a resolution of plus or minus 10 degrees? Absolutely not. represented by this upper left bullseye. If I did this, my VPD calculation would be wildly inaccurate. Now, conversely, would I want to invest in an expensive temperature sensor that has a resolution down to 1,000th of a degree? That's a bit overkill. I would want to reliably measure temperature within at least 1 degree Fahrenheit, something that meets in the middle. For environmental parameters, sensor density and location is a very important factor. You cannot achieve true control with a single temperature and relative humidity sensor placed in the center of your room or a thermostat on the wall. Sensors need to be placed within the canopy because the area within and around the canopy is what we are trying to control. Having a high sensor density allows you to identify microclimates and get a better overall picture of what is going on in your room. For multi-tiered rooms, we recommend a minimum of 4 temperature and relative humidity sensors per tier at canopy level to get an accurate reading of that room. Collecting data is great and all, but if you do not have a way to aggregate, format, and present that data in a useful way, there is no use in collecting it. Data should be presented in a clear way that allows you to make quick and informed decisions. That is why we spent so much time on sensor selection, design, density, as well as our cloud platform that allows you to drive consistency across the environmental control parameters.
Thanks, Durs. And executing consistent production is really about what you do with that sensor data that you collect. It's something that requires scheduling, planning, and needs to be predictable. So it's important to select genetics with that end in mind. Are they to be used for formulary, extraction, high-grade flower? What's the optimized plant flow process from cutting through curing, and how does it impact the plant rotation? Can you depend on this predictable growth pattern? Consistency is growth and the building block to make decisions that influence performance. It's how to plan for the future of cannabis business success. Most of us have seen one great harvest, but if it's not repeatable, then it's not good business. And without consistent environmental conditions, you won't be able to repeat that one great run you had. And you'll never know if you've cultivated your genetics to their fullest potential. Consistent production comes from control of the environmental factors that influence cultivation and curing. Have we created the environment to root as quickly as possible, veg for the shortest amount of time, get the best expression from every plant on every tier, every run? Consistent control of temperature, humidity, and CO2 allows you to answer those questions. Conventional non-integrated systems create inconsistent environments. Multiple non-integrated systems will fight each other to homogenize conditions, negatively impact airflow, and create swings in humidity that challenge the notion of consistency. Integrated systems deliver homogenized conditioned CO2-rich air directly to the plants. They also modulate to match the appropriate load in the space and give you precision 24-hour VPD control. Consistent production and scalability comes from the ability to do it the same way every time. Without a consistent environment, you'll be forced to be reactive in your cultivation practices and spend more time fixing issues than driving plant performance. What about efficiency, Durs?
Well, efficiency, the fourth and final financial pillar. Efficiency, it's the best way to increase your margin and become a low-cost operator. For most, when thinking about efficiency, energy efficiency is the first thing that comes to mind. But if your sole focus is to limit your energy inputs, quality will inevitably be sacrificed. It's not about limiting all your inputs, but maximizing each one as effectively as possible. And this can be done through investing in the right technology, taking a measured approach when designing your facility, thorough training, management, and cultivation strategies aimed at maximizing production. All of these are areas for you to lower your operating costs and future-proof your business for when the market compresses. I remember 10 years ago when it cost me upwards of $1,000 to produce a pound of high-quality cannabis. Today, many indoor growers aim to produce a pound for less than $300. And as these operations get more efficient, that number will become even lower. How much does it cost you to produce a pound? Now, cycles per year. Just think about what adding one more cycle per year per room could do for your bottom line. Most cultivars today require an average of 9 weeks to come to maturity. With time in between each cycle to clean and repopulate the room, that is 5 cycles per year per room. And that's if everything in your facility goes right. Targeted breeding for faster maturation times and pushing the plant to its limits metabolically is the only way to get to 6 or even 7 turns per room reliably. Depending on the scale of your facility, these extra cycles per year can mean millions to your bottom line. And you have to include EBITDA when talking about KPIs and efficiency. It is the best financial KPI to measure your business performance. It represents how well you implemented the 4 pillars we have been discussing today. By focusing on operational efficiency, cost of production, and EBITDA, you are setting yourself up for success.
Thanks, Durs. And in talking about efficiency KPIs, I'd like to take a moment to recognize the Resource Innovation Institute, which is a wonderful resource for those looking to baseline and better understand their efficiency KPIs. RII has collected lots of data and organized it in a way that's very useful for the cannabis community. You can reach out to their team and learn more about water, waste, and electrical efficiency and how your productivity is baselined against others. They're a great resource. They also touch on lighting efficiency and HVAC efficiency, which we usually discuss in pound per hour per kilowatt terms in order to consider the performance capacity as well as the efficiency of your HVAC system. Another element to efficiency is room utilization. How much of the room can you dedicate to canopy while still allowing proper airflow and a good work environment? We see on average between 70 and 80% room utilization. This is important because you only get one chance to build a facility the right way. When you think about fixed cost absorption, it's important to build a cultivation space that gets the most out of every square foot available. And lastly, we talk about labor efficiency and retention. Now, one way to think about it is how many employees per 1,000 square feet. It's a good way to understand what it takes to run your facility because labor can be a ballooning cost. And baselining the number of employees against the output of a facility will impact your SOPs. It can be a little challenging because every facility is different, but it is important. Do you need a larger than average team to apply IPM applications twice a week? How many people do you have for drying and curing? How much labor can you reduce with the appropriate technology and management? Even more granular, labor retention will impact the efficiency of your production facility. Creating a culture of success with quality training helps retain hardworking talent that makes minimum mistakes and grow healthier plants more efficiently. And then we think about influencing and improving. When most people think about efficiency, I think they're talking about using less power, less people, less anything. But to me, efficiency is really about getting the most out of every KW, every grain of water, every person, and every system in your cultivation facility. With 24-hour VPD control, you can run your lights at 100%, maximize CO2 uptake, fertigate appropriately, and get the most out of every cultivar, every cycle. 24-hour VPD control is just not possible with conventional non-integrated systems. Pocket dehumidifiers create heat, microclimates, and are not adaptive to the varied load profile in cultivation. Non-integrated air handlers limit your ability to homogenize room conditions and make it impossible to create consistent conditions in multi-tier environments. InSpire integrated systems were created to provide uniform canopy conditions that lets you best utilize VPD, develop set point itineraries per cultivar, and develop a repeatable process that optimizes plant health and reduces your costs of production. And as you can see, quality, quantity, consistency, and efficiency are driven by your ability to control the cultivation environment. A lack of control will be the biggest limiting factor in your ability to augment financial performance, while integrated HVAC systems are the opportunity to create action plans and influence KPIs with precision control. In summary, we went over a few pillars today and some KPIs that we found most important. We like quantity because it drives top-line revenue, quality and consistency because it drives pricing power, and efficiency because it drives margin. These metrics you track and the KPIs you choose will impact the pillars. And investing in integrated environmental control systems allow you to optimize the plant, other systems, and your facility performance. And right here, I wanted to take a moment to thank those in the industry that we really think are helping build better facilities. Photon providers like Fluence and Foch driving high PPFD cultivation. Fertigation companies like GrowLink, TGC, and Rhythm that have allowed us to fine-tune drybacks and the mineral balance. Racking providers like PIP and Montel that are and GrowGlide that are optimizing room utilization. Data collection from companies like Arroyo and Meter Group that allow us to see the impact of precision control. Crop Talk Media and the Future Cannabis Project for tackling the challenges of day-to-day cultivation. Genetics providers like Team Elite and Alien that develop great cultivars, and consultants like Catalyst BC and Zarterian Engineering that help bring in entrepreneurs' visions to life. We talk a lot about integration of temperature, humidity, and CO2, but it's the integration of understanding all of these people and systems that make cannabis businesses successful. We hope you enjoyed our presentation. And from here, I think we're going to dive into Q&A.
Hey, thanks, Jesse. Thanks, Anders. Fantastic job. I'm consistently blown away by the multidisciplinary challenge cannabis cultivation presents. Underneath these KPIs are the 10 plant growth parameters we've discussed in previous webinars, which require a unique combination of plant engineering and financial expertise. There's a lot to think about with these KPIs, and I would argue that KPIs for a cultivation business are significantly more complex than for a business like InSpire. All you cultivators and business owners out there working to maximize these KPIs every day deserve a ton of respect. Speaking of previous webinars, just a quick reminder that this and all previous webinars can be found on the resources page on our website. And with that, let's go ahead and jump into the Q&A. As a reminder, please everybody use the Q&A tab to ask any questions that come up as we move along here. So on our registration page, we asked everyone what the most important cultivation KPI was. We have categorized your answers into the 4 KPI pillars and ranked them in order from high to low. So my question for Jesse and Anders is, as the cannabis market evolves, does the business model change and therefore change the KPI focus? Furthermore, is there an ability to change these KPIs based on limiting factors?
Well, I think that really depends on the goals of your business, how you want to rank these pillars in terms of importance. For me, quantity, quality, and consistency always come before efficiency. I find them to be more valuable in, driving top line revenue and increasing my pricing power in the marketplace. But definitely as this industry evolves and we're going to have to shift our business models and we're going to have to become more lean and stay competitive. But I don't necessarily think that really changes the importance of these pillars. It just actually makes them more important, really.
Yeah, I think you're right. Like there's a potential to reorganize based on your goals. And I think certain people would value consistency from a brand awareness and delivery perspective, especially relationships throughout the distribution network. At the same time, something I think about a lot, especially in talking about retrofit markets, is what is your threshold for change? So you might all of a sudden realize there are 3 to 5 things that you can implement to drive EBITDA or to change, metrics that you can collect that are driving your action plans. But can you implement these action plans? What does it take from a sensor density perspective? What does it take from a labor perspective? How accurate is that data? Do you have the systems that allow you to get the control that you want to get, from lighting to fertigation to integrated HVACD? And I think that's one of the challenges and one of the thresholds we're at right now is that now there's new technology available that are allowing cultivars to really push the envelope on what efficiency looks like. And for me, I always like to think of efficiency in a plant growth perspective. Oftentimes we think about is how do we lower our cost of production? Well, one way to do it is to grow plants very efficiently and healthy and just grow more biomass, grow more secondary metabolites, which makes us much more efficient. So going from 40 grams to 60 grams a square foot will dramatically impact your bottom line in a number of ways. And what decisions can we make from an efficiency standpoint that will drive those decisions and drive that ultimate, metric that we collect?
Agreed.
That makes a lot of sense. Got to really identify all of those limiting factors and understand how they work together to create a facility, a high performing facility. That's great. Another one coming in here. Do you have a way to quantify how many more grams per square foot a facility can achieve with integrated HVACD?
How many more grams a facility can achieve it? Well, that's up to you as the grower, right? If you have the tools in place, I mean, it would almost be irresponsible for us to say you're going to get X amount with this tool. But to me, it's really up to you. The potential is there to grow and yield more, but you have to take advantage of it. And you also have to make sure that all of your other variables are dialed in and well managed to be able to maximize that yield. So there's no silver bullet, unfortunately. It's that symphony that we talk about all the time.
Yeah, I mean, I think a lot of times I think about optimizing phenotypic expression and really driving cultivar performance. It needs a baseline. You need to know what you're able to achieve with the conventional non-integrated system. What's your top line production? How are you measuring it? And then applying the ability or the performance of a new system to allow you to achieve bigger goals. For example, we've worked on several projects where they've had inappropriate technology that hasn't allowed them to adequately control for BPD. So, what is that worth? Well, their baseline is 28 grams a square foot. If they optimize that performance, could they achieve 65 grams a square foot? I believe so. There are other factors that need to go into it, but I think it has a lot to do with what their baseline for success is, what your performa is, what you're satisfied with, and where you think the market's headed into what you need to prepare for from a production standpoint. Do you need to be able to bring on cultivars, like you mentioned, that are low yielders, but give you brand recognition, give you relationships in the market that allow you to sell the product? There's so many factors that go into it, but being able to adapt to the changing market is a byproduct of building a good mousetrap in the first place.
Right. Exactly.
Mm-hmm. Yeah, so speaking of cultivars and genetics and propagation, we have an interesting question here. Bearing in mind the idea of consistency and stability, how do you think the propagation material would affect the development in terms of production? Micropropagation versus seeds, for example.
Great question. Obviously, micropropagation in tissue culture is going to help achieve consistency, right? You get a clean slate in terms of removing pests and pathogens and viral vectors from the space, because cloning those mothers time and time again, people call it genetic drift, but really that's the complete wrong usage of that term, genetic drift. What you're seeing from cloning mothers time and time again is the accumulation of pathogens, really, and the senescence of that plant's DNA, where it just can't duplicate cells as much. So micropropagation plays a super important role. It allows you to eliminate that mother square footage from your space, which increases efficiency and consistency. It allows you to mitigate risk by eliminating some of those potential for pathogens in your crop. And, from the TC plants I've seen, it's a really nice structure to a lot of them. One of the downsides potentially to micropropagation in staying current with the market trends is how long it currently takes to get new exotic cultivars through tissue culture and then have that sent back to you to throw into your rotation. Sometimes it takes so long that by the time you get that hot new cultivar back, it's already losing some of its hype, right? And so that is one of the challenges of micropropagation. But for a number of reasons, absolutely, it increases consistency across your canopy in your facility and reduces a lot of risk. So
I think you're totally right, Durs, and I agree with you. I think it does require some significant planning and understanding the cost benefit analysis, right? Like if you are able to remove a mother room and build another flower room, the likelihood of your cash flow is going up. But do you have enough time and space in the bedroom? Are you able to adequately control the conditions to be able to get enough growth from that plant fast enough that it meets the constrictive schedule for flower loading? I think that's one of the big fears, is that, taking on a bunch of little delicate plants and putting them in an environment that's not that great, people have had die-off. People experience setbacks that are tremendous financial costs.
Yep.
But anyway, it comes down to, like, we just worked on a facility in Colorado where they had a significantly long veg time because those plants weren't being grown in the appropriate conditions. So they weren't able to be fertigated appropriately. They weren't responding in a timely manner. Really understanding how to fine tune vapor pressure deficit as a tool, go in and measure it, and then take a look at understanding offset and changing set points allowed us to trim 10 days off their veg time. And 10 days off their veg time meant they could choose new cultivars now. They could explore new genetics. They could potentially bring in more plants so they could have a higher cull rate and choose just the winners that went into the facility.
mm-hmm.
So I think timing is really important, but when factored in and you get control, you can play either game you want to play with success.
Agreed. Well said, Jesse.
Highlights the importance of genetics, regardless of how you propagate.
Yeah. Hey, I see a question that came in here I'd like to address from Justin, if I can, real quick. What's
Please.
preventing a company from sending in their very best sample from their harvest in order to drive higher test results? Great question, Justin, because that's exactly what was going on for a very long time. The first cannabis testing lab was established here in Berkeley in 2007, and really until January 2018, that's exactly what everyone was doing. There was no people coming to your facility to take a statistically relevant sample from a batch. There was no standard batch size. There was really nothing to prevent you from gaming the system. And even back then, testing wasn't required either, like it is now in most states. But now with regulatory framework, they saw that being an area for gamesmanship. Being able to pick the best buds or even over dry a portion of your harvest so much that when you send it to the lab, you get a really high potency test, but then you hold the rest of your batch back at a higher moisture content to have more sellable weight. So the way they try and prevent that gamesmanship from happening is some states they require the labs to actually come to your facility and choose the samples themselves. And that prevents a lot of that from occurring, a lot of that, kind of gamesmanship. Not every state does that. And definitely this is still occurring some places, but I think it's a lot better than it was, in 2010 and back then where, you could game the lab results quite a bit, which was unfair, really. So.
I want to recognize that we're on the hour right now. Those of you who have other meetings to attend or tasks to attend to, we really appreciate you being here with us. This recording will be available on our YouTube channel and on our website within about a week. It looks like we still have some questions coming in here. So Jesse and Anders, if you guys don't mind, we can continue for another 15 or 20 minutes.
Sounds good.
Works for me.
Okay.
Yeah.
Fantastic. Okay. Where do we want to go here?
There's a there's two questions on VPD
Mhm.
that I think I can kind of answer at the same time here. One of them is from Jeffrey. Anders, as you know, there's a lot to play around with VPD. If you have an indoor grow with 1200 ppm and a temperature of 29C, the recommended VPD is 1 to 1.2. This is a high relative humidity. Thus, there's risk for botrytis. But at 60% RH, that VPD is 1.6. Isn't there a risk of closing stomata at that VPD? How do growers find the sweet spot? Yeah, great question. And and furthermore, along with that, from Ruben, how do you calculate VPD? What table do you use? How many metrics to calculate? Just temperature and relative humidity. Okay, so let me try and button that up. First of all, if you guys can't tell, we got VPD charts on VPD charts along our office wall, and it's something we talk about a lot. In general, when talking VPD, yes, there are a lot of recommended target ranges out there for VPD. There's not a whole lot of academic research to support those target ranges. In fact, I collected as many as I possibly could. A lot of them were just people repeating each other or guesses and being safe. What I have found is that if you strictly follow a VPD target range that someone presents to you, there can be problems. And that's because of variability, again, in sensors and how you measure VPD. You need more than temperature and relative humidity to calculate your leaf VPD. You also need your leaf temperature. So there are 3 data points you need to effectively calculate VPD. And for which chart do you use? There isn't one chart. The charts are variable depending upon the leaf temperature offset from actual temperature to leaf temperature. So you input that leaf temp offset, you get a VPD chart, and you can choose a general guideline, let's say 1 to 1.2 in the beginning of flower. Well, I'll look at that target range and I'll find which combination of set points my equipment can best achieve. Then after a few weeks of targeting 1.0, if my plants don't look that great because my temperature sensor wasn't very accurate and my VPD calculation was off, then I'm going to adjust my target range for my facility. So if I'm running my flower room at 1.2 with different sensors and a different IR gun to measure leaf temp, you might actually want to run your room at 1.4 because of how you measure it, where your sensors are located, etc. So I know that's a little bit in depth, but I hope I was able to clear that up a little bit. When it comes to the risk of botrytis running a high relative humidity, it's not about running a high relative humidity that can bring on botrytis, but it's the fluctuations that we saw in relative humidity, right? So lights go off without proper control, your RH is going to spike. And that drastic swing is going to cause botrytis to occur. So to be able to run a high VPD and use VPD as a tool, the prerequisite is control. You have to be able to precisely manage temp and relative humidity to be able to use it effectively in your garden. So
no, it's well put, man. It's a lot of complicated topics in there.
It is, yeah. So apologize if I went too nitty gritty on that, but hope that was helpful.
And we do this all the time, right? Like we measure each other's IR guns against each other's IR guns. And, like there's so many factors that go into really dialing in these rooms. But I think that's the beauty of seeing so much data and really trying to baseline what we think the best VPD targets are for different stages. And we've talked about this quite a bit and we've implemented it in multiple facilities and seen gains from it. But in the propagation environment,
way shorter veg times was one of the biggest things we saw.
In the propagation space, we sort of like a 0.5 to 0.7 VPD. In the veg space, 0.8 to 1.1. And then in flower, this can get pretty wonky, right? 1 to 1.5 potentially.
Yeah, 1.4, 1.5, start lower and work your way up to that 1.4 area towards the end. And in the last week, you might like you often hear, abandon the VPD chart depending on what your goals are and what cultivars you're growing. So, but again, don't take those recommendations as gospel.
No,
Use them as a guideline and then find your best target ranges based off of the way your plants look and how you're measuring VPD, temp, relative humidity, and leaf temp.
but we're talking about leaf temp, right? Which leaf, which tier, where in the room, your airflow affects that. There's so many other elements that you need to average in and really consider when you're choosing the temperature and humidity set points based on the VPD data that you've collected. There's just a lot to consider when you try to average all that together, depending on a week by week flower cycle or where you are in the process of cultivating and cutting and curing these plants.
Yeah.
Good deal. Good deal. A few more really, really good questions here. Anders, I think you see them as well. But maybe starting from the top regarding using the environment to enhance cannabinoids. The question is, in your experience, is there a way to manually tweak the environment to enhance the production of a particular cannabinoid or set of cannabinoids besides the implementation of decarb, UV, or heat once the crop is complete?
Once the crop is complete, I think that's the asterisk.
No, it's saying besides. So besides those factors during grow, is there a way to tweak the environment to enhance the production of particular cannabinoids?
I think just to be really clear, I think once you harvest that product, it's about preservation.
Mhm.
Once you're cultivating that product, it's about manipulation and steering. And for me, I mean, I see a lot of elements to helping that plant optimize its phenotypic expression and really get the most out of it from an environmental set point and light intensity perspective. I've seen a lot of recent research on spectrum deployment and focusing on, blue light to stimulate secondary metabolites, specifically terpenes. Also potentially UVA doing the same thing, which is mentioned here. I think we're still at the point where we haven't been able to create universal baselines per cultivar that really help us understand what the impacts of these other decisions are. And if you're not managing all 10 cardinal parameters, changing one doesn't really give you good feedback or accurate data on how to make an action plan.
Well, I would say to this question, why would you want to tweak the environmental parameters to bring out a certain cannabinoid? To me, that starts in the genetics, right? The genotype sets the baseline for what profile of cannabinoids that plant can produce. And then I use the environment as a way to pull out as much of that genetic potential as possible. So there might be some research out there supporting different lighting spectra or environmental crop steering techniques to maximize THC versus CBD or CPG or whatever. But I don't think that would ever be nearly as effective as just starting with a really good genetic, a really good cultivar that has been bred to specifically produce high amounts of the cannabinoid that you're interested in, Santiago. So I would say start with the genetics and then use the environment to maximize that phenotype as best as you can. So.
Great, perfect, great answer. Thanks, guys. Another one here from Michael Higgins. If we guess that a facility using traditional / legacy controls loses 10 to 20% of their production to failed microbial tests, what could that failure rate be reduced to with your integrated control system? Best guess he's asking for.
Best guess.
Thanks, Michael.
Well, 0%, right?
The reason we're confident in that is because if you can control the environment, you're not going to have outbreaks. Now that sort of creeps into the ancillary spaces, right? The culture of clean, how are you moving product?
Dirty cuts coming in.
What's contaminated and where's it held? What are the other pinch points? Where's your mop sink? I mean, there's so many factors that go into where these pathogens first start to form and then find their way into your space to proliferate. Mm-hmm. I think with an integrated system, with effective microbial filtration, biological filtration, running the appropriate air exchange with the appropriate levels of airflow through the canopy, we would like to see that reduced to 0. We don't like to see any of our partners ever fail a test, and we do everything in our power to empower them to not have to worry about that and instead focus on plant health, setup, staging, and performance. And I don't want that to seem like a cocky answer. It's just that there are continuous challenges associated with legacy technology that need to be managed on a regular basis with time and labor. And if they're not, these things will ultimately show their head. With an integrated system, we're not battling the technology and the mechanical devices. Instead,
It's a tool.
It's a tool. Exactly.
Yeah.
We're using it rather than blaming it.
And I guess if you look at the other side of that question, which we talked a little bit about earlier, was what's the differential between how much quantity and quality you can get using an integrated system versus a legacy or conventional non-integrated system.
Yeah, it's that building block approach, right? Like once you have precision control and it's measurable and accurate, you know what the baseline is for that cultivar. Can you go in and change the VPD? Can you change the set points in the room to get different performance out of the plant? Can you tweak it? Think about the genetic landscape. Where did this plant come from? How does it perform best? Are there conditions that you can show it to improve upon that baseline? Is it 1 gram per canopy square foot? Can you get that? Is it a couple? But until you have a baseline based on control, it's really hard to build and increase the yield. Otherwise, you're just sort of like, hey, this plant tolerates these stresses, and this is what I get.
Definitely. Well, Mike, I hope that answered your question.
All right, one more from Jeffrey. What is a reasonable level of precision control for HVAC when controlling VPD or relative humidity?
Reasonable level of precision control. Well, I think 1 to 2 degrees Fahrenheit, and to be safe, maybe 3 to 5% relative humidity is really good control in a room, especially during the lights on, the lights off transition. That is the hardest snapshot in the day in the life of a grow room to control the environment in, because you lose all of that sensible energy from the lights right when they shut off automatically. And so you lose all of that heat, and you have to have a piece of equipment that can react quickly and accordingly to that drastic change in load, right? Because when that light drops, relative humidity is relative. So when the light's gone down, the temperature wants to drop, and now your relative humidity is proportionally higher in that space. And that's where you get those big spikes coming up, right? That spike, again, like we talk about over and over again, is what causes so many problems. And so being able to manage that within 3-5% during that swing is definitely great to have. Until these systems, I've never been able to have that control. So it's a kind of a game changer, right? Because now you can start using environmental crop steering techniques, changing your diff between day and night.
You mentioned day and night. I think that's a good one, right? Because for me, it was always sort of like, hey, man, I have this level of control when the lights are on, and when the lights are off, I'm just sort of praying. Like, oh man, I don't really know how I'm controlling the temperature when I don't have heat from the lights, heat from the compressors. I don't have extra heat to capture. So having ancillary heat in that unit that allows me to play with VPD in the lights off period
and maintain set point when you have to remove so much moisture.
I don't want to be, forced to do a certain thing because my environment can't be controlled, and say, okay, I have to accept this differential between day and nighttime, which I know causes a dramatic stretch in the plant and is ultimately going to reduce my yield and change the way I defoliate and train my plants. So for me, having that ancillary heat is the opportunity where it's like, let's play with that diff. Let's have a little bit warmer right at the beginning of that lights off period to trigger respiration, to allow that plant to better process and let the system to better remove moisture during that lights off period. So yeah, I think there's a balance in understanding control for a 24-hour period. And then, like you said, the transition is a really big one.
wonder if people can tell that we're like sitting right across from each other and staring at each other.
Literally
talking.
right across from each other, talking about cannabis all day, every day.
Yeah. Oh man. Well, I think that was all the questions, huh, Brian?
I think we got them covered.
Yeah, and feel free to reach out to us. Anyone who's still here, shoot us an email. We love to talk, and we'll try and follow up with anything that wasn't answered in the webinar. But feel free to reach out, and we'd love to talk to you about anything cannabis related and driving your financial performance and mitigating risk.
Yeah, I really appreciate you all showing up today. And, I hope you guys got something out of this and learned something today. So we really enjoyed putting this together, and keep a lookout for more webinars coming up soon where we got more in the works. So if you have some cool topics you'd like to hear us talk about, again, shoot us an email. We're always going to answer and talk. So, yep. Hope you guys have a great one too.
Terrific. Thanks, everybody. Catch you next time.
Thanks, everybody. Appreciate you.